So for exponents, we have 4 to the third power. What does that mean? What does 4 to the third power mean? Yeah.
4 times 4 times 4.
4 times 4 times 4, right? 4 times 4 times 4. Okay, so we've got this, which is called the base. That is the base. And then, of course, we've got this, which is called the exponent. So we've got the base raised to the exponent. The base tells us what we are multiplying. The exponent tells us how many times we are multiplying it. The whole thing is considered a power. So if you ever see them talking about powers, it's the same thing. They're just talking about dealing with an exponent. Okay, but they might say write it as a power. And so they want an exponent, a base to an exponent. Okay. All right, so one thing that we've talked about a couple times now through the homework, and it's come up a couple times, is when there's a negative involved. Okay, we need to know that there's a difference between -2 to the 4th power and a -2 to the 4th power. Okay, there's a difference here. This is -2 as the base. The base is a -2 here. If it's not in parentheses, then the base is a +2. And we just have this negative hanging out front. Okay, this is like a multiplication here. This is whatever's going on here, I'm going to multiply by a negative. So the difference here, right, -2 4 times, whereas this is going to be 2 4 times with that negative out in front. And this is going to change things. It's going to be important because if you think about this, a negative times a negative is a positive. This is going to end up being a positive number. This is going to end up being a positive 16. Whereas this, I've got one negative in there. It's going to end up being a negative 16. So it's going to be important that we pay attention to the parentheses versus not parentheses. Because that's going to change our answers there. Anytime that we have an even exponent, it's going to change that answer. If it's an odd exponent, it doesn't make a difference. But because it does matter half of the time, we want to definitely get in the habit of doing parentheses when we should and knowing the difference. Okay. All right. Questions on that? All right. All right. What is 4 to the 3rd power?
48.
Not 48. What is it?
64.
It is 64. Let's talk about our calculators for a second. If I can find one. Oh, okay. Let's make sure we can use exponents. Most of us have this type of calculator. So to use the exponent, if you look on the left side, there's that little arrow button. That arrow up, it's called a caret. This right here, this is our exponent button. Okay, that's our exponent. If you just need to square something, like 7 squared, I would type in 7 and then the x squared. That'll do 7 squared. But if you need something else, like a 3rd power, 4th power, 10th power, whatever, this is your button. So you type in your base, then that caret, and then the exponent. So if I want to do 4 to the 3rd power, I would hit a 4. I'd hit that caret button for the 3rd, so I'd hit 3 equals, and that's going to give me my answer. Okay? So that's how we do exponents on the calculator. It's important to understand what it represents, right? But you're going to see a lot of problems where you need the calculator. Okay? So we said this was 4 times 4 times 4, and it equaled 64. Great. What about 4 squared? What does 4 squared equal?
16.
16. We know that, right? 4 times 4, 16. What about 4 to the 1st power? 4. Okay. now we're getting into the new stuff. 4 to the 0 power. It is not 0. It is not 4. Nope. Why 1? Just a guess? It is 1. It is 1. Let's take a look at why. We got to follow the pattern. Okay? There's a pattern going on here. Every time I subtract 1 from my exponent, what are we doing to my number? I'm dividing by 4. Right? So if I continue that pattern of every time I subtract 1, I'm dividing by 4. 4 divided by 4 gives me 1. Okay? Anything to the 0 power is equal to 1. Anything. Anything to the 0 power is equal to 1. I would write that down in my notes. Anything to the 0 power is equal to 1. I don't care if it's a number, a negative, a letter, doesn't matter. Anything to the 0 power is equal to 1. X to the 0 power is equal to 1. Negative 27.5 to the 0 power is equal to 1. Anything to the 0 power is equal to 1. And it's for that reason, right? We're dividing by 4. Every time we subtract an exponent, we're dividing by that base. Okay, now we're going to get a little crazy. Got negative exponents now. Okay, probably haven't seen these. We're looking at negative exponents. Follow the pattern. What is this going to equal? Levi? 1/4. I'm continuing to divide by 4 here. Every time I go to the right, every time I take away one of my exponents, I'm dividing by 4. Divide by 4 again. That gives me 1/4. For the negative second. Not 1/8. Nope. 1/16. 1/16. For the negative third. 1/64. So I want you to look up here and I want you to see the pattern that's emerging. I had 4 to the third was 64. 4 to the negative third is 1/64. 4 squared is 16. 4 to the negative second is 1/16. 4 to the first is 4. 4 to the negative first is 1/4. So when you have that negative exponent, it just becomes 1 over what it would have been if it was positive. And that is the pattern. This is 1/4 to the first. 1/4 squared. 1/4 to the third. That's a big takeaway from today. Because that's something new. That's something that we haven't learned before. Is if we have a negative exponent, we can change it to look like this. It's 1 over the positive version of it. So if I have 5 to the negative fourth, I should be able to look at that and realize that that's going to be 1 over 5 to the fourth. That's a big part of what we're doing today, is being able to look at negative exponents and change them into something that we can deal with. I want you to type 5 to the negative fourth power in your calculator. 5 to the negative fourth in your calculator. What do we get? Big decimal, right? Yeah, big decimal. Okay. The thing about this is, I don't want decimals today, okay? I don't want decimals. So we can't just type this into a calculator. We have to change it over to this first, okay? Do 5 to the 4th on your calculator. Just 5 to the 4th. What do we get for that? 625. So if they ask you what is this equal to, I want you to change it over to 1 over 5 to the 4th, and then we'll make it 1 over 625. That is going to be our answer. Our answer is going to be in fractions here. Okay, we're putting it in fractions. We're not putting it in decimals. If I ask you this question after break, right, a long time from now when we take the quiz on this stuff, if you give me that long decimal, I'm going to mark it wrong. I don't want the decimal. We want them as fractions. We want to know that because we have a negative, we are moving it here. Okay. Any questions right now that you have on this? Okay. So let's say I've got x to the negative third. What am I going to rewrite that as? X to the negative third. What can I rewrite that as?
X to the 1 over x to the third.
1 over x to the third. Good, right? Because that's what we talked about. We've got a negative exponent. We're going to move it to the denominator, make it 1 over the positive version of that exponent. Okay, very important that we're doing that. Okay, let's say that we had x squared y to the negative third. I'm going to start throwing these new situations at us. When we see a problem like this, we cannot have negative exponents in our answer. Okay, we're never going to have negative exponents in our answer. We always have to change it over to positive exponents. We need to rearrange it. We need to do something so that we only have positive exponents. So you can think of this as a multiplication problem, right? If there's no symbol in between, it is multiplication. So we've got x squared times y to the negative third. Well, what do we know about that y to the negative third? We got to change that, right? This will become 1 over y to the third. No problem. I don't remember.
I'll go through it.
It's not the whole thing, I'll tell you that. It's either
I
through.
think I know when to stop.
Yeah.
Okay, cool, thank you.
So we take that y to the negative third. We know, just like we did up here, that's 1 over y to the third. So this would be the same thing as x squared times 1 over y to the third. I want to combine these. I want these into 1. Okay, I want one fraction out of it. I don't want this multiplication with a fraction and that, right? I want it a little bit clean. If I'm multiplying, all right, I can multiply the tops, multiply the bottoms. That's going to give me x squared over y to the third. X squared over y to the third. The big idea with this, because you're going to see a lot of things where you're going to have to start moving stuff, is if it's a negative exponent, it needs to move to the other part of the fraction. Okay, if it's a negative exponent, it needs to move to the other part of the fraction. What I mean by that is right now, everything's a fraction. It just might be over 1. Everything's a fraction. So if I've got a negative exponent, I need to move that down to the bottom of the fraction now. If it's got a positive exponent, it's going to stay right where it is. But a negative exponent, that needs to move to the other part, and we need to make it positive. I want you to write what you think this is going to simplify to. A to the negative fourth, B to the fifth, C to the negative second. What do you think that's going to simplify to? Keeping in mind that we're going to move some of these things. Okay, check somebody around you, see if they have the same thing. See what they have. All right, what is this going to look like? What do we think this is going to look like? Nobody's willing to give it a shot. Justin? Yeah, there you go. Remember we said if it's a negative exponent, then it needs to move. If it's a positive exponent, it stays. So that B is going to stay right where it's at on the top. And then the negative ones, we need to move to the bottom to get there. Questions on that? Did we have that and we were just too shy to say anything? Okay. If not, hopefully you understand it because you're not asking questions. So hopefully that means you get it now. What if I had this? Talk to somebody about it. What is that going to equal? What do you think that's going to equal and why? Wow. You guys are like already on break, huh? Super quiet. I know this is your last day in school, but we're still here. Any ideas? What do you think? Levi? Yeah, it's just gonna be x to the second. It's just gonna be x squared. Because now this is a negative exponent. We said negative exponents move. Negative exponent needs to move. So it's in the denominator. I'm gonna move it up top. I'm gonna move it up. I'm gonna change it to a positive. So that's just x squared. Okay, so if it's on the bottom, it moves to the top. If it's on the top, it moves to the bottom. Do we get the general idea? Okay. Let's look at one here, and then we got to move on. Okay, but this is going to bring all of this stuff together that we just talked about. And maybe something new. We'll see. Okay, I want you to simplify this. Do the best you can on it. Think about what we've talked about. Rearrange that. Remember, no negative exponents in our answers. Another 10 seconds, then we're gonna talk about it. All right, I'm not gonna ask for an answer because you're not gonna tell me anyway. So, let's walk through it. Okay, first of all, the new thing that I want to point out, okay, is if you have 4x to the 0 power, that is not 4x to the 0 power. Just like we talked about with the negative, this is different than this. There's a difference, right? Order of operations, that 0 here in this problem only applies to the x. That 4 is just on its own. What's the exponent of something that doesn't have an exponent? 1. 1. Right? That's 4 to the first power. We know 4 to the first power is 4. We talked about that. So this is just x to the 0. This is 4 to the first power. They're separate. Okay? They're separate. That comes big into play if you have like 3x to the negative second and you're moving that x. You're not moving 3x. The 3 is going to stay there because it's got a positive exponent. It's got an exponent of 1. Anyway, so that 4, and I'm going to talk about what goes up, what goes down here. That 4 is going to stay right where it's at because that's got a positive exponent. It's going to stay up top. It's going to stay there. What is anything to the 0 power? 1. So do I even need that? Do I need to say times 1? No. So anything to the 0 power, you can just cancel out. You can just get rid of right away because it's not going to change anything. And then we said anything with a positive exponent is going to stay. Anything with a negative exponent is going to move. So this is a negative exponent, so it's got to move to the bottom. This is a positive exponent, so that's going to stay right where it's at. Negative is going to move. Okay, if it's a negative exponent, it's going to move. If it's a positive exponent, it stays. That's the big takeaway here. Hopefully you have something in your notes about it. You should, because we already wrote it. But a negative exponent moves, a positive exponent stays. Okay. Any questions about this? Okay. I know this is typically homework time. I've got 3 small properties to show you. 3 small things to show you here. Told you there's a lot in this section. So we're going to learn what we can, and we're going to come back from break, and we're going to pick it back up. And we're going to make sure we remember. So let's say we have x to the 3rd times x squared. X to the 3rd times x squared. We know what these represent, right? X to the 3rd is x times x times x. X squared is x times x. I want to simplify this. When we simplify, I only want 1 of every base. I don't want 2 x's here. I want 1 x with an exponent. So if we think about this, if this is x times x times x, and this one is just x times x, if I was going to rewrite this as 1 exponent, what would it be? X to the 5th, right? There's 5 of them. This is equal to x to the 5th. What do you think our shortcut is? Add the exponents. So if you're multiplying with the same base, add the exponents. Okay? Multiplying with the same base, add the exponents. So if you're multiplying with the same base, add the exponents. It has to be the same base though. You can't take x to the 3rd times y squared and get something. It has to be the same base. X to the 3rd, x to the 2nd is x to the 5th. We add those exponents together. So that would be like y to the 10th times y to the 7th. Y to the 10th times y to the 7th would be y to the 17th. Right? We simply add those exponents together. Okay, that's one of them. Told you I got 3. That's one of them. Okay, next one that I have, let's say I have x to the 7th divided by x squared. X to the 7th divided by x squared. Well, if we think about what this means, what it represents, this is 7 x's up here. And this is 2 x's down here. And we know if we're multiplying something on top and bottom, they cancel each other out. So what's going to happen is those are going to cancel. What am I left with here? X to the 5th, right? X to the 5th. What's my shortcut for this one? Subtract the exponents. So if we're dividing with the same base, we subtract the exponents. Okay, dividing with the same base, subtract the exponents. Thank you to those of you that are taking good notes here. It's really important since, you know, the next lesson that we do on this is 3 weeks away. Yeah, it's not ideal. That's why we take notes. Okay, questions on these two? Pretty straightforward, right? You're multiplying with the same base, add them. You're dividing with the same base, subtract them. I got one more, and there will be a video up on Schoology on this in case you forget. It'll be there. But the last one that we're talking about is something like this, and this is called power to a power. Power to a power means we're taking an exponent, we're raising it to another exponent. Now, if we think about what this represents, what this means, right? This is something squared. So whatever's in that parentheses, we need to have that twice, multiplied together. So what this means, this is x to the 3rd times x to the 3rd. Now, we already know how to simplify that. What does that equal? X to the 3rd times x to the 3rd. X to the 6th. Can I jump straight from here to here? You multiply the exponents now. You multiply the exponents. Okay? So if you have power to a power, power to a power, multiply the exponents. Okay. I know that this is a lot, and it's a lot in a quick amount of time. But that's why we have notes, so that we can look back at it. We're going to try it tonight. We're going to come back tomorrow. You guys will be virtual, but we'll come back tomorrow, and we will talk about it. We'll go over any questions that you had on the homework. Okay? Any questions right now? Okay. So your homework's on big ideas. Do tomorrow. We'll talk about it tomorrow. We will not do another lesson tomorrow. Okay? We will relax and have a nice day before break after we go over the homework. If you go home, if you have questions, you can hop back on. Otherwise, give the homework a shot. We'll talk about it tomorrow.